Tomorrow, before school, bring in your cereal.
That right, man.
Can't never come back without a fall.
That right.
What?
Michael Jordan got cut before he made the NBA. Exactly.
It is a true
He's
statement.
still in it. He's still in it.
He was the number one recruit.
Is that our
Football, college, class.
He got cut from the JV team the sophomore year.
Is that our
That's like the whole
Okay.
classic thing.
Yep.
Cut Michael Jordan.
Okay. All right, here we go. Unit 3 is all about trigonometry. All right, periodic relationship between two variables occurs when the output values demonstrate a repeating pattern over successive equal length intervals. Okay, so at this point, I don't know what trigonometry you've done already, but a periodic relationship you are aware of right now is if I to the first is I, and I squared is -1, and I cubed is -I, and I to the fourth is 1. Remember that? Then what happens when you go to I to the fifth? It goes right back to I, because powers of I repeat themselves every 4, right? That's periodic. So if I do I to the 6th, it's the same as I squared. And so on and so on and so on. That's what it means to be periodic. So the period is the length of the inputs it takes before you start repeating. So for this, it would be 4. Because after 4, you start repeating. So let's look at example 1. Okay, he tells us the period's 4. Does that make sense to everybody? That you have a shape, takes 4 units to get the shape, and then the next 4 units are the same shape. I'm looking at example 1 on my notes, right? So the period's 4. Does that make sense to you when you look? He tells you that, but did you figure that out on your own? Yeah. Because you're going from -1 to 3 on the x's, and then you just start repeating again from 3 to 7, and then you can imagine from 7 to 11 would be the same picture, and so on. All right. Draw 2 additional periods on the axes above. Okay, can you do that? So you're going to draw exactly the same shape. Come on, Cole. You're going to draw exactly the same shape. All your trig functions are periodic. That's why we're starting with this conversation. You're supposed to be drawing here in example 1. That's okay. It's all right. Example 1 is the first picture there, the graph of F. Perfect. Beautiful. Where did you end? If you do exactly 2 more periods, where did your picture end? At 15. Well, when x is 15, yeah. And that makes perfectly good sense, right? Because we're repeating every 4. So we would go from 7 to 11, and then from 11 to 15. All right, let's look at G. The portion of the graph is shown above. This is periodic. What is the least possible value of the period? So what do you think the period of that is? I hear 3 and I hear 5. Do I hear anything else? All right, let's take a vote. How many think the period is 3? Okay, how many think the period's 5? All right, now some of you didn't vote, so what do you think the period is? He thinks 4. Anybody else think 4? No, I'm just saying raise your hand if you think it's 4. All right, tell me just in words, what is the shape that's being repeated. Don't we have a horizontal line and then like a triangle? And then it repeats itself, another horizontal line and a triangle. So how long is the horizontal line? 2. How wide is the triangle? 3. To make a period for this picture, you need a horizontal line and a triangle. After you draw the horizontal line and the triangle, isn't everything else just a duplicate? So that means your period is the horizontal line and the triangle, so the period's 5. Now those of you that said something else, have we convinced you? We're counting across. How many steps do you take to make the line and then make the triangle? All that together. Congratulations on your award, by the way. Okay? All right. Using the function g, find the following values. Now notice your picture stops at 9. And they're asking you for like g of 14 and 72 and negative 17. So let's see if we can figure that out. Can you figure that out? What do you think g of 14 is going to be? Don't say it yet. See if you can figure it out. Talk it over with your partner, and let's see what you can come up with. Yep, you're trying to find the y value, right? G of 14.
Well, you know, 3 to 5, and 9 to 10. So that's be 14.
6 is close.
Okay. Anybody come up with a thought for 14? What'd you come up with, Alex?
So what I did is I subtracted 5 2 times from it, because like since it's cycles of 5, then you can subtract 5 or add 5 any number of times and it'll be the same. So then I got g of 4, and g of 4 equals 7.
All right, let's talk about that for a second. First of all, does his logic make sense? Every 5 in this problem, not always, but in this problem, every 5 we repeat. So notice that g of 1 is exactly the same as g of 6. And you guys noticed that. You said, I keep getting 7, 5, 6, 7, 7, and then I get 7, 5, 6, 7, 7. I just keep getting the same y values over again. Every 5 they repeat. So he said 14 is, well, 14 is 10 plus 4. 10 is 2 5s. So isn't this just 2 complete periods? So he said I can ignore that part, because 2 complete periods just bring me back to my starting point again, and I need to go 4 more. I love that logic, that's great. Gabby? Yeah.
So for B, I subtracted 70.
Time out here. So we're at G of 72. All right, so what was your thought there?
I subtracted 70 from 72 because that's a multiple of 5. And I got G of 2, which then came out to be 6.
I Carla, but she did the same thing Alex did, right? She's had bigger number to deal with. Why is she taking out 5s? She said it was a multiple of 5, so she divided out 5. This means what? 5 goes into there how many times? 14. So that's 14 groups of 5, so 14 periods, and then 2 extra units. Beautiful, beautiful, beautiful. What about negative 17? How did you do with that? Declan?
I just thought about it using the graph, and so I did, like I subtracted the multiples of 5, so I just had -2, so I basically just started at 0 and then I just went back 2.
Okay.
Or did you just say G of -2?
Huh? What did you do?
Like, I feel like I did the same thing. Like, I just, like 15 is a multiple of 5, so I got the, like, there's 2 left over, like -2 left over, you know, -2 on yours, 7, so, go ahead, explain.
That's okay. There's something about that bothers me a little bit. Did everybody get anything else?
What do you do?
Gabby?
Enzo, what'd you do?
I just wanted to get it
Seven's right.
into the positive number, so I added 20, which then got me to G of 3.
Okay. That makes more sense to me, but I'm not, you guys that went backwards, the only thing about traveling backwards is, I don't know, something about it unsettles me.
The graph
but
on here goes to -2.
If it worked for you, huh?
The graph on here goes to -2.
Yeah, I know. It's just the process bothers me. But if it makes sense to you, that's great. Gabby's makes more sense to me because like her, I like to be positive. I like to think about my graph as progressing this way instead of going backwards. But that's just a problem I have. The idea is every 5 you're gonna repeat. Every 5. All right, next. We don't have a graph this time, but we are told that it is periodic with a period of 5 again. We've got a table of values, and somehow we're supposed to find all of the missing ones. So there's a whole bunch of ones there. All right, so let's start with A. See what you can come up with. Oh, I get it written down up here. They tell you the period is 5. You would have no way of telling that from this information. So they tell you the period is 5.
Wait, they don't give us 4 things. How is
I don't know, that's the problem. See what you can figure out. Yeah. If you get A, go ahead and try B and C and D, keep going. What'd you get for h of -2? Were you able to get an answer? 0. How many of you got 0 for h of -2? Because every 5 units repeats. So whatever happens at 1 happens at 6. So this one's -2. Whatever happens at 3 happens at 8, and so on. I want -2. Keep in mind, my period's 5, so won't I back up 5 from there? So h of 3, that's gonna be the same as h of 3. And this one's gonna be the same as h of 1. that okay? How about the next one? H of 9. Well, first of all, let's find h of 9. What would h of 9 be? 3. And how did you get 3? Because 9 will be the same as 4. So h of 9 is 3, so now I need to find h of 3, which is actually in my chart, so that is 0. H of 5k minus 3. I'm actually going to think of that myself as negative 3 plus 5k. Well, here's why. Because the period is 5, and that means every multiple of 5, I repeat. So isn't this is like saying negative 3 plus 5, negative 3 plus 10, negative 3 plus 15, and those are all going to be the same as h of negative 3. Because if you add 5, because that's the period, we're just right back at the same spot. If you add 2 5s, 3 5s, negative 8 5s, it doesn't matter. If you add multiples of 5, you don't change. So this is the same as h of negative 3. Well, now I got to figure out h of negative 3. Any thought about that? Fred, you have a thought?
I got 2.
How did you get 2?
Because negative 3 is the same as
7?
7. I don't really know what it.
Yes, you do. What's negative 3 plus 10?
7.
Yeah, so you have to add or subtract multiples of the period. And since the period is 5, I can add 10, or 15, or 20, and add whatever multiple of 5 I want. If I'm adding it 7, the answer is going to be 2. So 7 minus 10. So h of negative 3.
What if you keep on adding 5 but it's not on the chart?
What do you mean?
Like, if it was like h of negative 4, or like,
The chart, in order for you to answer the question, the chart has to have a way of getting the period relationship out of the numbers in the chart.
okay. So they won't.
They have to.
Okay.
They have to. All right. Let's see. As a result, we're able to consider periodic functions horizontal translation. Okay. In example 4, the period of h was 5, meaning that we could translate the graph horizontally 5 units and end up with the same graph. That's what this is right here. We've been talking about that. Let's look at example 5. The graph of f is periodic with a domain of all real numbers. That means it keeps going. 2 full periods are shown. Find all input values, so everything that we can input that would yield an output value of 1. Well, what are a couple we see right on our graph? 2 and 6, right? Well, we could keep going, but we would keep going. You would be older than me before you could stop, right? You're going to keep going forever and ever. So could we express that rather than individually listing 2, 6, 10, and by the way, we gotta go the other way too. How could we write that? 2 plus what? Not 6, 4. And probably X isn't the best choice of letter. He used K before, and there's nothing sacred about that. But X is kind of a special variable, so we won't use X. We'll say that. Now, that's okay, but tell me what K is. What's K?
Plus or minus, or like plus or minus negative, or plus or minus infinity, right? 8 positive.
Now be careful. Can K be, when you say you're adding multiples of 4 here, can K be 1/2? No. So what kind of numbers does K have to be?
Whole numbers.
Whole numbers for sure, but integers. Because, can't we go backwards? So we need negatives because our domain is all real numbers. So this would be one option. Another option would be to say 2 plus 4k, where k is a whole number and then put a plus or minus on there. That would accomplish the same thing. This would add and subtract all the wholes. This adds all the integers. It accomplishes exactly the same thing. All right, number 6. I haven't looked at it in a while, but I believe a problem like this, example 6, was on the actual AP exam. I believe it was a full response question, but it could be wrong. All right, so the figure shows a large clock mounted to a vertical wall. All right, rather than me read it, you read it with your partner. See if you can figure out, it's only 2 parts, see if you can figure out A and B. I'll work on it for a second and we'll compare notes. Let me draw my picture.
Okay. the time, 30 seconds.
No, that's a 12. Clock period, clock is fine. Oh, is that an hour?
Where are you getting the 128? That's not the
So 30 seconds.
That's
30
a
minutes is behind 60 minutes. No.
Okay. So, first of all, would you agree the situation's periodic? Yeah. Every time the hand goes around, that would be one period, right? And then it's gonna go around again and again and again. So what is the period of this function? 30 minutes. So wherever the clock is, I'm just gonna start listing some points. Wherever the clock is at time 0, however high it is at time 0, it's exactly the same height at time 30 and exactly the same height at time 60. Would everybody agree with that? So how high is the hand, the tip of the hand, at time 0?
128.
When it's sticking straight up, it would be 120 plus the other 8. So all of these are gonna be 128s. Are we clear on that? Everybody good on that? Now, where is the hand halfway in between here? So at 15, in other words, where would the hand be at 15? Wouldn't it be straight down? So its height when it's straight down is 112. So that would be, this would be 45. I'm not sure how many of these I'm gonna need, so I'm gonna stop there for now, but would everybody agree with that? Okay, so these points right here are when the hand is as far away as it can be from the floor. And these points are where it is as close as it can be to the floor. Would you agree? So can I begin labeling any points on here? J, what do you think J is?
The lowest 150.
J, remember, there's no scale here, but this is a coordinate axis system. That is a point I am plotting. So that point is low. And the lowest it can be is maybe 15, 112. And then this one would be the next time it's low, which is 45, 112. Then?
At 15 or 45 would be 120.
Be careful. Remember, the clock is going around in 30 minutes. So, yeah. They always throw that kind of crap in there to screw around with your brain. So read it very carefully. So all the way around is 30, so halfway around is 15. Right? Oh, now we think we can label all the points, he says. Well, I can surely label this one because this is the high point between 15 and 45, so isn't this one 30?
Yeah.
128? And then what would this one be over here? 0, 128? So now we're going strong, but we still need G and K. Now, G and K are where the hand's over here, right? So that Y is going to be 120. And what are the X's going to be? Well, halfway between here, so this is 7.5, 120. And this one will be 22.5, 120. Again, there are no axes shown. So you have to imagine that there's, like here's the y-axis right here, and then all clear down here somewhere is the x-axis, and this is the point 0, 128. Okay, got it? Perfect. Now, there would be other options, because remember, this thing keeps going, right? So we happen to get lucky and be able to start with 0, but that isn't always gonna work. Keeps repeating, so you can have lots of different possible answers. Are we set? That? All right, so that was A. Now B. I circled these two because he's isolated those, and we're gonna look at that interval. So on this interval from G to J, and his picture is better than mine, so you can look at his picture. Which of the following is true about the function? H, the function itself. What can you tell me? This little stretch. Which of those statements is true? Which one?
This is you.
B,
Positive.
as in
This is-
boy?
That's you. This is so I'm just like,
You good with B?
Positive? Well, it's, how do you determine if it's positive?
going up.
How do we determine if a function is positive or not?
It's above
If it's above the x-axis. Are these points above the x-axis?
Yeah.
Everything in this problem is positive, right? Everything in this problem is positive. So the function is positive and it is decreasing. Now, if you were thinking D, you were thinking negative and decreasing, you weren't looking at the function, you were looking at the slope, at the rate of change, okay? When we talk about the function being positive, we mean it's above the x-axis. Y is positive, and all these y's are positive, so B is the correct answer. Good job. And then finally, describe how the rate of change is changing. So describe how the rate of change is changing. Why? Concave up. Bingo. Remember, concavity gives us information about our rate of change. So it's increasing because we are concave. Wonderful, that's awesome. Okay, let's turn to the back of the next page. So to check your understanding, take a moment with your partner and let's see if you can answer these questions. Check your understanding.
the pages keep on falling out.
Sorry.
No, that's my fault. I'm like 40.
You want a stapler?
Huh?
You want a stapler?
I think it's actually maybe, yeah.
Oh, this is below that. Oh, it's just because it's going back.
And it's just because there's so many.
It's because
Yep, there are a lot. That's all.
That's more math you don't learn from
the
ours.
ours.
I'll probably do your mathematics.
No.
I love exploring. It's already something good. It's already
The whole period.
Oh, I was the first person to say that. False. False.
Today I would
I literally drove in playing that song.
ask Enzo, I literally was doing
Oh, no.
I literally walked through the two periods. Started doing the running man. Ask Enzo.
Dude, you know how I got out of bed?
Hey, guys, we're trying to figure out our check your understanding. Let's check our understanding.
No one cares about your green today.
It's not a green, it's actually running.
Owen,
I'm just gonna say the POC.
Sandy.
Yeah.
So the previously. I think that's something my nose was the best decision ever.
that mean? Yeah.
If it asks us a period, could we put like P equals 12, or do you want us to just say period as well?
Well, you can, it doesn't matter which one it is. So, we're probably your period will have a unit.
Which in this case would be.
So here it was minutes.
This one is out.
Yeah, you could, they're all.
Life is all about
Yeah.
We should put that in horizontal.
What's this point code right here? Should I go ahead and change the size?
So,
Where's your
10
grade
times
school?
30,
What's all the school?
Well, so did I, but I have a unit.
One at a time.
So that, you're supposed to be wearing your throwback stuff.
Are you down
So then you should have been in.
that's 30.
That's one of the changes.
Then where did
If we
you
had 30, you'd be right back here at the top, right? So then,
Is that showing?
3.
You weren't in college sweatshirt. It's hot in this room. I'm sorry. You need to be in uniform.
I'm not in it.
You are.
He is, I'm not. What's going on?
Ties, you ever got some ties all over the place?
We're supposed to wear grade school stuff. You wore yours.
Tie.
Can't believe I actually had a shirt.
Yeah, but you're not wearing it. You're not wearing it. You're wearing your sweatshirt. Today.
Man.
Let's go yesterday. Not to you, but to others.
Playing golf with him. Oh, you do? Yeah, he comes up with him.
All right, let's talk about our answers. I'm checking your uniform, making sure you're following.
Him and Brady come
6 or 7.
Him and Brady come for
You don't have the same birthday too.
wait, don't tell me. June 11. Yep.
Eyesight, I don't have such.
Either June 9th or June 11th. I think it was June 9th or June 11th. Spencer was 63 days older than me.
Alright, there's no way, there's no way.
I didn't know if he was a year today
Oh, yeah.
or just under a year.
And honestly, if you were homeschooled,
Don't give me that smug look.
all right. What did you come up with? Describe how the water level is changing throughout the day. What? We're rising and falling. Of course, you probably, most of you have been to the ocean, so you know there's these things called tides. So what does this mean? Every 12 hours, there's a high tide, and every 12 hours, there's a low tide, right? Going up and down, or in and out, in and out, in and out. Okay, so the period is 12 hours. Figured that out. And we already talked about it. Okay. What do you expect to be the water level at T equals 33? What did you decide?
4 feet.
4 feet. And how did you get that? What was your thought process? 12 times 3 is 36.
Go back
And we just went backward 3. All right, anybody do anything different?
Subtracting
24, because 24 is actually on the graph, right? So we get rid of that 24, we gotta go to 9. Okay, perfect. At which time, this is a throwback question to see how much we remember. At which times is the water level changing the fastest?
I said 12T plus or minus 3. So it could be 9 or 6, or 9 or 3.
Okay, you're kind of there. Tell me what you wrote down again.
So 12T plus or minus 3.
And what's T?
The amount of hours times.
T is another value.
Yeah.
So tell me why. Tell me your logic on that.
School t-shirt. If it's, say T equals 0, it could be 3 hours Or it could be 9 or 8 or 2, same as 9.
When on a curve does the rate of change the most?
Point of inflection.
Point of inflection. Very good. Point of inflection.
Good job, Mitch.
So where are my points of inflection? Let's just list some of them. We've got one at 3. We have one at 9. We have one at 15. Now wait a second. What do the points of inflection have in common? They are all 6 apart. So I like this a lot, but I'm thinking maybe that should be a 6 instead of a 12 to get all of them. Because the points of inflection, look at your graph, the points of inflection aren't 12 apart.
Yeah. Oh, yeah, you're right.
Right? So, and I would prefer myself, it's 3 plus or minus 60, how's that? Okay? Yeah. So every 6 hours, we're gonna have a point of inflection. You guys are amazing. All right, 3.1 is due on Monday. Let's move on to 3.2 because now there's some memorization that you're going to have to do.
I'm confused about if, can we go back to like the first page of the test?
Yeah.
The graph on the first one? Because this graph of g of x, we said it was 5. So would,
On the very first page.
yeah, this
Yeah.
graph of g of x,
Mhm.
if the period's 5, does where x is -2, is that g of 0?
No,
Or is
no,
that,
no. -2 would be the same as 3. They're 5 units apart.
no, like,
Oh.
just like looking at this, like, is this point 0, and then the next,
I'm not sure I know where you are. I mean, this is on a grid, Olivia, so the points are, I mean, you have your coordinates.
yeah, well, like,
Yo,
is
I
this
guess I get what she's
0?
saying. No, I see what she's saying. But no, your numbers are already on here. If you're gonna go backwards, you're gonna go backwards from 0, not from some random that's on the sheet. But you're gonna start from 0. I don't care. I'm just, no, I'm saying that it's like interesting to tell me that sounds about what she's saying. Big out?
All right, so now we're getting ready. We're gonna talk a little about sine, cosine, and tangent today. And there's stuff you just have to memorize. Remember on the AP Pre-Calculus exam, there is no formula sheet, there's nothing given. You are 100% completely on your own. Luckily, we haven't had a whole bunch of stuff we had to memorize, but now we're gonna get some. We're gonna get some that we have to commit to memory. So, first thing we do is talk about how angles are measured in trigonometry. So that all of us in the whole wide world, up and down the hall and other countries, can have a conversation, and we all know what each other is talking about. All of our angles will be measured in standard position. Standard position means that your vertex is at the origin, and that the initial side of the angle is on the positive x-axis. So every angle we draw, unless we are given some other kind of weird directions, every angle we draw will start right here on the positive x-axis. And then it will proceed in a counterclockwise manner. This is called the initial side of the angle, and this is called the terminal side of the angle. So your rotation begins on the x-axis, positive x-axis, and you rotate up. If you rotate down, which is also possible, then your angle would be a negative angle. So positive rotation is up and around, negative rotation is down and around.
Are you labeling that angle theta?
Yes,
You just want to flex.
yeah. trigonometry uses a lot of Greek alphabet letters, so theta is just a variable.
It goes all the way around, like, and it's on the other side of the x-axis, would that be positive or negative 180? Would it
Well,
always be
it depends
positive?
which direction you go, it's all about direction. If you go this way, it's positive 180.
Oh, there's always gonna be an arrow showing us.
Yes, yes. Okay, now, speaking of like 180 and stuff, so our labels, this is where we begin our rotation, so that's 0. We're progressing this way, so this is 90, 180, 270, 360. I'm gonna go ahead, I can't remember when he gets into it, but I'm gonna go ahead and label those in radians as well. And we're gonna talk about radians more later on, but let's get used to what those look like. So 0, 0. 90 is pi over 2. 180 is pi. 270 is 3 pi over 2. And 360 is 2 pi. So start getting used to that right now. I don't know if you've ever seen a radian in your life. We'll get to it, it's in the next section. But I just want it to be part of your initial picture. So you start processing that pi over 2 is straight up. Pi is the same as 180. All right, so that's the way we're gonna label our angles, okay? Now, let's look in the box. Given an angle in standard position and a circle centered at the origin. All right, so here we go. We have a circle centered at the origin. And we don't know the radius, we'll call it R. It determines, obviously it determines a point on that circle, right? If I consider a little triangle in there, would you agree that the coordinates of this point are x comma y? I don't know how far I went over, but I went over some and up some, so that would be x comma y. All right, that's a setup. Then sine, cosine, and tangent are defined in terms of that circle. So sine, the sine of our angle, is defined as the vertical displacement over the radius, or y over r. Now, for those of you that paid attention in geometry, that fits perfectly with SOHCAHTOA. What does sine mean in SOHCAHTOA? Opposite over hypotenuse, okay? We are getting used to thinking about trigonometry in terms of circles and not always triangles, all right? So if you want to think SOHCAHTOA, it's absolutely perfect. It won't always work, I'm just warning you, but in this case, absolutely. So then what's cosine? Cosine is defined as x over r, and tangent is defined as y over x. So those are 100% things you need to know. Tangent is very, very special to us. First of all, tangent's associated with slope. Does that make sense to you? That tangent would be associated with slope, y over x? Because it's y over x, it can also be defined as sine over cosine. Because if you put that over that, the r's cancel and you get y over x. Okay? So these are absolutes. We gotta know them. We're not gonna survive one more day if we don't know. So with that we're gonna learn. All right, let's look at example 1. He's drawn a circle centered at the origin with an angle of theta in standard position. Got point P up here. Which of the following is true about the cosine of theta? Don't make it harder than it is. What do you think?
Yes, A.
Yeah, it's A. Why is it A? Because what's cosine? X over R, and R is clearly
Radius.
3. Yeah, radius 3. So yeah, easy, so easy. All right, how about B? Or 2, I mean, number 2. Anybody want to guess what the sign is? Be careful. Sine is y over r.
Oh, it's
Y over r. So what's your y coordinate at point P? -4. So what's your sine? -4/5. Right? What's your cosine? +3/5. And how about our tangent? -4/3. So the trigonometric functions can be negative depending on which quadrant you're in. Because since cosine is x and sine is y, those can be negative, and you're gonna get negative values sometimes. All right, I'm gonna stop there. And overall, I have to say that I was so pleased with your multiple choice yesterday. Most of you did a really good job. Each of those was worth 2 points, and most of you, many, over half of you missed nothing on that. You got all your multiple choice right. So that is magnificent. Keep up the good work. A huge portion of your exam is multiple choice. So we